As the final section of this chapter, we will discuss about the power. In many practical problems, we do not need to know the energy, or we do not want to know the total energy that we gain or we do by our system. But we want to know that how fast the energy can transfer to our system or transfer out of our system. So we will define the power that delivered to our system or by our system as P is equal to dE by dt. So this is the rate of change This is the rate of change of the energy of the system. It's the rate of change of the energy of the system. This is a general definition. It means that you can use this definition for any kind of energy, not just the mechanical energy. But for now, if we look at the mechanical energy only, and if the process of energy exchange is the work, because we look at the mechanical energy only, so the process of the energy exchange or energy transfer is the work. So the change of the energy must equal to the work done on the system or work done by the system. So we must have that. If we concern only the mechanical energy, we must have that P is equal to the dW by dt because the change of the energy equal to the work done on or by the system. Anyway, you have to be careful when you interpret this equation. In this equation, dW is the amount of work done during the time delta t. Okay, it is not the change of the work. These two equations are similar, but we have to be careful when we interpret the second equation, because in the first equation we can say that dE is the change of the energy of the system. But for the second equation, we cannot say that dW is the change of the work of the system. There is no work of the system. We have only the work done on the system or the work done by the system. So we cannot keep work, we cannot store work, but we can store energy. We can keep energy but not work. So this dW is the amount of work done during the time delta t, or I can change this a little bit during the time dt. Okay, so be careful on this. Now let's go to some mathematical detail. From the meaning of dW, it is the work done during the time dt. And if during the time dt our object moves with a small displacement dr. Okay, if we have an object and it moves with a small displacement dr during the time dt, and if the force exerted on this object is F, okay, so we have that in this situation we have that dW is equal to F dot dr, right? dW is equal to F dot dr, which is the definition of the work. So dW by dt is equal to F dot dr over dt. But this term dr by dt is nothing but the velocity of the object, right? Because here we assume that there is no deformation, so it means that the motion of the point of the application of the force is the same as the motion of the object. So dr is the motion of the point of the application of the force is equal to the displacement of the object, and dr by dt is the velocity of the object. So we have that this is equal to F dot dv. So, F dot v. So this is the expression for the power. If you know the force that applied to the object, and if you know the velocity of the object, you can calculate the work done by this force. You can calculate the power delivered by this force by this scalar product. The SI unit of power is watt. W-A-T-T, or the big W, watt. The name watt is come from the name of a great engineer, James Watt, who developed the steam engine. And by definition, you can see that you can see that 1 watt is equal to 1 joule per second, which equal to 1 kilogram meter square over second square. This is the SI unit of the power, but you can have the customary system. For example, the US customary system the US customary system, they use the horsepower. The HP. And by definition, one horsepower is equal to the 746 watt. It is also interesting that you can express the work in terms of the power and time. For example, and the most familiar unit is the unit of the energy in terms of the kilowatt hour. 1 kilowatt hour is equal to the product of 1000 watt times 1 hour, which is 3600 seconds. Okay, and this equal to the 3.6 times 10 to the 6th of June. The unit of kilowatt hour is usually used to measure your electric energy that you use monthly, and we also use the word of the unit or the energy unit. So when you look at the bill of your electric power, they may say that you use 10 units of energy, and that is equal to the 10 kilowatt hour that you use that month.